The scorching New Mexico desert, a vast wilderness. July 16, 1945. It's teeming with activity. This is the Trinity test site. Here, a new and terrifying age is about to dawn. 5:29 a.m. The world's first atomic bomb detonates with the force of 20,000 tons of high explosive. 10 miles away, observers feel the explosion's heat on their skin. The flash is brighter than 20 suns. It's the biggest man-made explosion to date. The world will never be the same again. But the biggest bang is produced by a chain reaction of tiny particles. And none of it would happen without conventional high explosives. John Rhodes is the director of the Bradbury Science Museum at Los Alamos, New Mexico.
Today we think of our contemporary nuclear weapons as the absolute zenith of destructive power, but they can trace their roots back to low-energy gunpowder, which then over time became high-energy, high explosives.
The long line of explosives, from gunpowder to TNT, leads to this, Little Boy. 28 inches in diameter, 10 feet long, Little Boy is a small package designed to deliver an explosive force equivalent to 15,000 tons of TNT. Inside are two masses of a heavy metal called uranium, a target and a bullet. Kept separate, there's not enough uranium in one place to sustain a chain reaction. The bomb is said to be subcritical. Conventional high explosive fires the bullet at the target, bringing the two uranium masses together. The bomb becomes critical. Now, there are enough neutrons bombarding the unstable uranium atoms to initiate a devastating release of energy. This is the principle of a fission bomb. The uranium nucleus accepts a neutron. It splits into smaller atoms and more neutrons. These neutrons proceed to split other uranium atoms. It's a chain reaction. Each reaction releases a vast amount of energy in a very short time. The gathering energy blows the bomb apart with a massive blast. It all happens in a split second at 8:15 a.m. on August 6, 1945, 1,900 feet above the Japanese city of Hiroshima.
This is the uranium weapon that was used on Hiroshima. It starts with the detonation of conventional high explosive to fire the shell against a uranium target. Subcritical, critical, boom.
In that moment, the bomb kills 70,000 people and injures as many again. Many more die as a result of radiation sickness. And Little Boy has a big brother. Los Alamos scientists have developed another bomb.
And they wanted to bring into its use plutonium, which had just recently been discovered, which was more energetic, basically more bang.
This is Fat Man. Unlike the gun-type device of Little Boy, Fat Man uses implosion to compress the subcritical assembly of another unstable metal, plutonium.
The idea is you take a core of plutonium, you surround it with a jacket of high explosives, and you detonate it.
3 days after Little Boy delivered its deadly cargo, Fat Man explodes with the equivalent of 21,000 tons of TNT above the city of Nagasaki. But whatever the method of detonation, the terrifying effects of an atomic bomb remain the same. An instant after detonation, a fireball, a luminous mass of air, starts to expand. Even from 50 miles away, a nuclear blast is many times brighter than the midday sun. Looking directly at the blast could destroy your light receptor cells, permanently burning a large spot into your retinas. A massive blast wave surges outward, destroying everything in its path for mile upon mile. Approximately half of the energy goes in blast, about a third in heat, and the rest in radiation.
The first and most obvious is blast. There's a tremendous shock wave that's propagated outwards from ground zero where that weapon is detonated. A shock wave that can take down buildings, can move vehicles, can twist railroad tracks. You not only have blast, but you've got heat approximating near the temperature of the sun, so that anything around is immediately vaporized, immediately incinerated.
The fireball increases in size and cools. The vapors condense to form a cloud containing solid particles of the weapon debris and small drops of water sucked into the fireball from the air. Nitrous acid and oxides of nitrogen make the cloud appear red or brown. As it cools, the water droplets condense, changing it to white, just like an ordinary cloud. But the contents are far from ordinary. The cloud is full of deadly radioactive particles. As they blow downwind, they fall to the ground and contaminate thousands of square miles. Find yourself in the contaminated zone, and you could be exposed to a lethal dose of radiation. A low dose will damage your cells, but your body should repair itself. A higher dose may overwhelm your body.
The effect of radiation on the human body in these extraordinary doses is really only known from Hiroshima and Nagasaki. It has the ability both to penetrate and to do extraordinary cellular damage, as well as serious burning to any exposed part and internally.
But despite its countless horrors, the nuclear genie is out of the bottle.